Hello students, welcome to the maths class. Students, we have started the chapter Conic sections and we have discussed its objectives. First, different conic sections. Second, parabola and its properties. Third, ellipse and its properties. Fourth, hyperbola and its properties. Then we have discussed how to convert the given equation of parabola to the standard form. Today we will discuss the equation of ellipse reducible to the standard form. Students, we have learned the standard equations of ellipse. There are two types of ellipses. So, in both the cases, you can see that center of the ellipse lies at origin. It is symmetrical about it. So, here center is 0, 0. Now, next type is there when center is shifted from 0, 0 to some other point. How we can apply the results to that type of ellipse. Now, look here. First, I have taken this is a standard form where center is lying at origin. Now, when this point is shifted to some other point, same as in parabola, here I have taken in the first quadrant, say it is a alpha beta, but it may be shifted to any other point also, anywhere in the quadrant also, on the axis also. So in this case, firstly, in the standard form, we are having an equation x square upon a square plus y square upon b square is equal to 1. So it is also written as x minus 0 whole square upon a square plus y minus 0 square upon b square is equal to 1. Here the center point is subtracted from the x and y. So on simplifying we will get the standard form. Now when this center point changes from 0, 0 to some other, it is alpha beta. So in this case equation changes to x minus alpha whole square upon a square plus y minus beta whole square upon b square is equal to 1. In place of 0, 0 we will get alpha beta. So here x minus alpha can be written as capital X whole square upon a square and y minus beta whole square can be written as y square upon b square is equal to 1. Now you can see that it is comparable with the standard form. So when we reduce it to the standard form, then we can apply all the result related to this ellipse. Now let's do one example based on it so that it is clear to you. Show that the equation 3x square plus 4y square minus 12x minus 8y plus 4 is equal to 0 represents an ellipse. Then find its center, length and equations of axis, eccentricity, foci and the directrices. We have to find all these. Now first of all, given equation is 3x square plus 4y square minus 12x minus 8y plus 4 is equal to 0. We are having a term x square also and y square also. So firstly separate the terms containing x and y, then do the perfect squaring method. So here firstly 3x square minus 12x, 4y square minus 8y and shift the constant term to the other side. So it is minus 4. Now from the first two we can see that 3 is a common factor. So 3 into x square minus 4x plus here 4 is common. So 4 into y square minus 2y is equal to minus 4. Now for completing the square, here we will add half of coefficient of x whole square. So coefficient of x is 4. When you half it square, so it will become 4. So we will add and subtract 4 from this bracket. So that From the first three terms, we get a perfect square. Similarly, in the second also, it is y square minus 2y. So, for completing the square, we have to add and subtract half of coefficient of y, that is 2 whole square, and 1 square is equal to 1. So, here I have add 1 and subtract 1. So, it is equal to minus 4. Now, you can see that from the first three terms of the bracket, we are getting a identity. It is of the form a square minus 2ab plus b square. So, separate these three terms. It becomes x minus 2 whole square. That is of the form a minus b whole square. Similarly, in the second bracket, from the first three terms, we will get an identity. It is of the form y square plus 1 square minus 2 into y into 1. That is of the form again a minus b whole square. So, it can be written as 4 into y minus 1 square. Now, from here we can see that 3 into minus 4, that is minus 12. When minus 12 shifted to the right hand side, it will become plus 12. Similarly, 4 into minus 1, it is minus 4. Shifted on right hand side, we will get plus 4. So, on simplifying, here minus 4 and plus 4 will cancel out. So, we are left with 12 only. Now, from reducing it to the standard form, right hand should be 1. So, divide the whole equation by 12. On solving, we get here x minus 2 whole square upon 4 plus y minus 1 whole square upon 3 is equal to 1. Now, we have to reduce it to the standard form. So, x minus 2 can be taken as capital X. So, it becomes x square upon 4, and y minus 1 whole square can be taken as capital Y square upon 3 is equal to 1. Now, we can compare it with the standard form, that is x square upon a square plus y square upon b square is equal to 1. This is a horizontal ellipse. So, we will apply all the results related to the horizontal ellipse to this ellipse. Now, here when you compare it, a square is equal to 4 and b square is equal to 3. So, from here we will get the value of a and b. A is equal to 2 and b is equal to under root 3. Length of major axis is equal to 2a. So, put the value of a here. It is 2 into 2. Answer is 4. Next is length of minor axis. It is 2b equal to 2 into, put the value of b, that is under root 3. Now, next is eccentricity of ellipse is given by b square is equal to a square into 1 minus e square. Now, here put the value of b and a, we will get the value of e from here. So, b square will become 3, a square is equal to 4 into 1 minus e square. So, shifting 4 on left hand side, 3 by 4 equal to 1 minus e square. Now, here shifting 1 also. So, minus e square is equal to 3 by 4 minus 1. On simplifying, we will get minus 1 by 4. Here minus cancel with minus. So, we are left with e square is equal to 1 by 4. On shifting the square, we get the value of e, that is 1 by 2. Now, center of the ellipse is given by x equal to 0 and y equal to 0. So, from here x minus 2 equal to 0 and y minus 1 is equal to 0. On shifting, we get the center as 2, 1. Next is the equation of major axis. It is y is equal to 0, capital Y equal to 0. So, put the value of capital Y is equal to y minus 1. So, here y minus 1 equal to 0. This is the equation for the major axis. For minor axis, capital X is equal to 0. So, on substituting the value, we get Ax minus 2 is equal to 0. The foci of the ellipse are given by x is equal to plus minus AE and y is equal to 0. Now here we are having a value of capital X, we are having a value of A and E. On substituting all the values, we will get the value for the foci. So here x minus 2 is equal to plus minus value of A is 2 and value of E is 1 by 2. We have calculated above. So on solving, here we are left with plus minus 1. We will consider both the signs. First case is there when x minus 2 is equal to 1 and second when x minus 2 is equal to minus 1. Because in case of ellipse we are having two foci. Okay. So from here x is equal to 3 and here x is equal to 1. Similarly for the y, so when you substitute the value of y, we will get y minus 1 equal to 0. So from here y is equal to 1. So two foci are firstly 3 comma 1, secondly 1 comma 1. In this way, you can reduce the given equation to the standard form of ellipse and apply the properties related to the standard ellipse. Students, I hope the topic is clear to you and you can solve the sum related to the topic given in your SNAP homework. Before starting the work, go through the links guided in the SNAP homework. Rest we will continue our next class. Thank you.